Okay, welcome everybody. In this lesson, we are going to talk about synthetic division and the factor theorem. So just to give us a couple of guiding points for this lesson, the goal is to figure out how is synthetic division similar to polynomial division and how is it different. Obviously, they got to be kind of the same, kind of different if it's a alternative strategy. Another question is what even is synthetic division and when can it be used? And lastly, how can we use division to determine if a divisor is a factor of the polynomial? That is something that we've been talking about, but just want to reiterate the importance of that. So you're due now divide and determine if the divisor is a factor of p of x. Pause this video, go ahead, take a second, and work out this problem. Okay. So hopefully you've had enough time to work out this problem. To use this, we're going to do the box method, and notice our polynomial has 4 terms, which means we're going to have 4 columns in the box, like so. We are dividing by 10x minus 7, so we're going to cut it in half and do 10x on top, minus 7 on the bottom. And first things first, 30x to the third, our leading value in our polynomial, has to go inside of the box. Now that I have values on the outside, I say 10x times what gives me 30x to the third, and that would be 3x squared. Now that I have that, 3x squared times negative 7 is going to be negative 21x squared. And I know, looking at my next term in the polynomial, I need to get negative 121x squared. So I need to take away 100 more x squareds in order to get that value. So now I'm asking myself, 10x times what gives me negative 100x squared, and that's going to be negative 10x. Negative 10 times positive 10 gives me negative 100. X times x gives me x squared. Now negative 10x times negative 7 becomes positive 70x, and I need 160 x's, which means I'm going to need 90 more. Now I need to ask myself 10x times what gives me 90x, and that's going to be 9. 10 times 9 is 90. 9 times negative 7 gives me negative 63, and I look at my next term and I realize I need negative 61, so I have too many, and so my remainder is 2. So if I'm saying what is 30x to the third minus 121x squared plus 160x minus 61 divided by 10x minus 7, I would say that this is equal to my quotient 3x squared minus 10x plus 9, as well as my remainder included here. My remainder is 2. And whenever I have a remainder, I'm just going to write it over my divisor, 10x minus 7. Nice. Hopefully you're remembering the box method. If not, hopefully this drags your memory a little bit from the weekend. So, first things first, here are 2 division problems now that we're kind of warmed up. So take a second. What do you notice, and what do you think is happening here? Our first problem says x to the third minus 16x squared plus 62x plus 11 being divided by x minus 8. What do you notice? What's going on? I'm kind of front-loading you here to see if you can recognize any patterns. Remember that our brains are hardwired for patterns too. The second example is 4p to the third plus 25p squared plus 18p minus 25, all divided by p plus 5. Again, what do you notice with the weird thing below it? What do you think is happening? What's going on? Take a second to pause this video, write down what you notice and what you think is happening. Okay. Hopefully you had a chance to take a second and observe, kind of like look at what's going on within this without me even needing to introduce it. I want you to start understanding like what's going on here. What are some key things that you might have noticed? So hopefully you'll notice that x to the third has a coefficient of 1. Negative 16x squared has a coefficient of negative 16. Positive 62x has a coefficient of positive 62. Positive 11 has a coefficient of positive 11. And so all of those matched with the values right there. Similarly, in the second example, it's 4p to the third, we got 4. Plus 25p squared, we got plus 25. Plus 18p, we got plus 18. Minus 25, we got minus 25. So hopefully that jumped out to you. Another thing that might have jumped out to you is x minus 8 became the opposite value. From factored form to something else, it became opposite. Same thing, p plus 5 became the opposite value on the outside. And something else you probably noticed straight away is that we've got these arrows popping down. And so this number is always popping down first. Now, I'm curious to see if you can notice what happens after. How do we get all of the other numbers that are not highlighted? What is happening between 1 and 8, and how does that affect the rest of the problem on the left? What is happening between 4 and negative 5, and how's that affecting the problem on the right? Maybe you notice that 1 times 8 gives you positive 8, and then we just added negative 16 plus 8, and that gave us negative 8. Then once we're here, we take negative 8 times 8 again, and that gave us negative 64, and then we added vertically. Now we've got negative 2 times 8. That gave us negative 16, and then we add vertically. It would be the same thing over here. 4 times negative 5 gives us negative 20. If you add positive 25 minus 20, you would get positive 5. Multiply positive 5 times negative 5, you get negative 25. Add vertically, you get negative 7. Negative 7 times negative 5, you get 35. Add vertically, you get 10. So my question is, how is that quick strategy with just numbers related to the box method that we know and have come to like so much? What about these problems are similar? What about them is a little different? How can I use the box problem to understand what's going on within the just number problem situation going on here? And so what I hope you notice is that the remainders stay the same. The remainders don't change. They're the last value in the box. They're the last value at the end of this new strategy here, which we're going to call synthetic division. So the remainders always stay the same. I also hope you notice that the quotient x squared minus 8x minus 2, right? This is my quotient. That is related to this guy down here. This is 1x squared minus 8x minus 2. That guy should match. Similarly, over here, my quotient, 4p squared plus 5p minus 7. This becomes 4p squared plus 5p minus 7. It matches. And essentially, we're doing the same thing that we're doing in the box, but we have way less writing that we end up doing. Well, because we're shorthanding it, we end up having to write in our quotient a little bit later at the bottom. But yeah, this is synthetic division, guys. I don't know about you. I really enjoy the box, but I also really enjoy synthetic division. So synthetic division is the fast way of doing polynomial division without having to write all of the variables to start, essentially. And synthetic division is really fun, and it's not perfect by any means. It has a couple things that you got to be mindful of, but I'm pretty confident that you guys are going to enjoy doing synthetic division. Okay, so here's a couple rules though. Number 1, you can only use synthetic division when the divisor is the form x minus a. This means like if you have a number in front of x, you cannot use synthetic division for this. So if you have something like a polynomial divided by 2x minus 1 or a polynomial divided by 5x plus 4, you cannot use synthetic division. You have to go back to the box. So I don't want you to forget the box, but know that sometimes you can use synthetic. Okay? If you have any missing terms, like it goes like from x squared to plus 4, right? You need to use a 0 as a coefficient, otherwise it will mess up your math a little bit. As we saw, the last number in synthetic division is going to be our remainder. We can have a remainder of 0, we can have a remainder with a number. And then the one thing, since we do like save some time by only using coefficients, no variables, at the very end we do need to add the variables back in to rewrite the quotient. And with that, what's tricky is the quotient will always be 1 degree less. But I'm hoping that since we're familiar with the box method, we see that now. So like, for example, in this first polynomial, where we have x to the third minus 16x squared plus 62x plus 11, right? That is a third degree polynomial, and our resulting quotient was x squared minus 8x minus 2 from the box, and similarly, this needs to be 1 degree smaller. If we look at the second example, it was 4p to the third plus 25p squared plus 8p minus 25. And since we're dividing by 1p, it's going to reduce by 1p. We see that here. We got 4p squared plus 5p minus 7 in our box, and it's going to be the same thing in our synthetic. We just have to actually like go in and add the p squareds and the p's, or the x squareds and the x's. So that's like one little downside. Like synthetic can be very fast, but then we're going to have to add in what we were leaving out to begin with. So let's do a couple examples. So determine if we can use synthetic division or not, then divide it, and lastly, determine if the divisor is a factor of p of x or not. So our first example says b to the third plus 6b squared minus 14b minus 45 divided by b plus 7. I think probably the easiest thing to do first is I like to write it as an L, but not everybody does. But this is just my personal preference for synthetic division. And I like to start with the coefficients, that very first thing I think a lot of us noticed, which is b to the third has a coefficient of 1, 6b squared has a coefficient of positive 6, negative 14b has a coefficient of negative 14, minus 45 has a coefficient of minus 45. So we're just observing that these coefficients are the numbers that go here. Okay. And one other thing, just to get in the habit, is there was this arrow that dropped down. So we're going to drop down that number first. Always, always, always. Then we noticed that whatever we were dividing by was the opposite sign. So I know I'm going to have opposite of positive 7 is negative 7, but I want to show you why. We have the potential factor of a b plus 7, and if it is a factor, that means we get an x-intercept. If we have an x-intercept, we have a 0, and we find zeros by setting them equal to 0. So if I take away 7 on both sides, that's how I get b equals negative 7. So not only is it opposites and like tying into how we know graphs look, but it actually like comes from this arithmetic. Okay, so we write that guy on the outside. And now we're ready to rock and roll, friends. We're going to take 1, multiply it by negative 7, and that gives us negative 7. Write it in the next spot. Then we're going to add vertically. What is positive 6 minus 7? That's negative 1. Start over. What is negative 1 times negative 7? That's positive 7. What is negative 14 plus 7? We just add vertically. That's going to be negative 7. Okay, what is negative 7 times negative 7? That's positive 49. Okay, what's negative 45 plus positive 49? That is going to be plus 4. Again, the last number is always going to be my remainder. And now all of the values 1, negative 7, that can be rewritten as my quotient as 1b squared, because I originally had b to the third up here, minus 1b minus 7. And since I do have a remainder, I should probably write plus 4 divided by b plus 7, the value I was dividing by. So my final answer from synthetic division is b squared minus b minus 7 plus 4 over b plus 7. I do have a remainder here. So I was able to use synthetic division because I have b plus 7. That's an allowed form. I was able to do the synthetic division, and I know that b plus 7 is not a factor. Why is it not a factor? That's simply because it has a remainder of 4. The factors theorem says that an expression x plus a is a factor if and only if the remainder is 0. It expresses that in a different way, but it's not a factor because we didn't get a remainder of 0. All right, let's do another example. 5n to the third minus 53n squared plus 81n minus 81, all divided by n minus 9. First things first, are we able to use synthetic division or not? Since it is divided by n minus 9, yes, we are allowed to use synthetic division. I like to write out my coefficients first. 5 minus 53 plus 81 minus 81. Something to be careful of and to note is it's really important to put the signs and be extra careful when you're writing down synthetic division. Probably the number one mistake people make is they move too fast and then they forget a sign somewhere. So that's just one thing to be mindful of. And again, we're going to set n minus 9 equal to 0 to get that opposite value to put on the outside of my synthetic division. And after I drop 5 down, now I'm ready to say, what is 5 times 9? That's positive 45. And I put it in the next spot. Now I can add vertically. Negative 53 plus 45 is negative 8. Once I have a number written on the bottom, on the outside of my synthetic division, I start over. Negative 8 times 9 is negative 72. Now I can add vertically. Positive 81 minus 72 is 9. Now I can say, what is 9 times 9? That's positive 81. And negative 81 plus positive 81 gives me my remainder of 0. So now that I see that there's a remainder of 0, I can automatically go and say, yes, n minus 9 is a factor because it has a remainder equal to 0. And if I was to write my quotient, all nice, remember I started with degree 3. So this is going to become 5n squared. An exponent less. It was to the third power, now it's to the second. Minus 8n plus 9. That's my quotient. Pretty cool, right? So as long as you're careful with the numbers, I think a lot of you are really going to like synthetic division. It's pretty cool, but again, remember, you can only use it if it is of this form. If my factor instead said divided by 3n minus 9, you would not be able to use that. So you got to be extra careful that it's of this form to be able to use synthetic. One last thing, the factor theorem says that x minus a is a factor if and only if, or of p of x, if and only if p of a is equal to 0. Okay, so we just did this. We saw that we got a remainder of 0. That's wonderful. We knew it was a factor because of the factor theorem, but really, what the factor theorem is saying is that when we plug in a to the original polynomial, we should get 0 if it is a factor. So we know this last example has a factor. We got a remainder of 0. But we want to plug in a to show that it's true both ways. Not only that there's no remainder, but also when I do plug it in, that this is true. This is like an alternate way to use the factor theorem. So my original polynomial is right here. This dividend, that's my original polynomial p of x. So p of x, I'm just going to write it out, is 5n to the third minus 53n squared plus 81 minus, n minus 81. And I want to know what the heck p of a is going to be. So I'm setting up my problem, and the a value is coming after the x minus or the n minus. So the a value is right here, 9. Or when we set it equal to 0, notice we got n equals 9. So we're going to plug in 9. Everywhere there was an n, we're going to plug in a 9. Notice I used parentheses. And so now we got to do 5 times 9 to the third minus 53 times 9 squared plus 81 times 9 minus 81. And hopefully it's equal to 0. So 5 times 9 to the third, 9 times 9 times 9 is 729. So that becomes 5 times 729. 53 minus 9 squared, 9 times 9 is 81. So I'm just going to plug this in. Plus 81 times 9 minus 81. And then it just becomes a calculator problem. 5 times 729 is 3,645. 53 times 81 becomes 4,293. 81 times 9 is 729. And 81 is 81. So we just get to adding all of these things up to one another, and we get 0. This shows that p of 9 equals 0, which verifies the factor theorem. So one way, instead of testing all of these things, is if we think we know a factor, we can plug it in. We can evaluate the function. And we're going to see a little bit more of that in the next lesson, but I just wanted to bring it up and let you see how you could use that. But again, the main part of this lesson was to figure out if we could use synthetic division or not, divide the polynomial, and lastly determine if the remainder is 0, we have a factor. If the remainder is not 0, we did not find a factor of our original polynomial. So on the back side of your notes, there is an assignment with 6 problems for you to practice. So first, you got to figure out which strategy you got to use. Are you going to use synthetic, or do you have to use the box? Then you actually need to do the division. So in some of these examples, you will be using synthetic, and some you will be using the box. You got to still do it. No opting out, even though you can't use synthetic. We do have another strategy in our toolbox. After you finish the division, you still need to determine if the divisor, what we're dividing by, is actually a factor of the polynomial or not. Use the factor theorem in words. Be like, by the factor theorem, since the remainder is 0, we found a factor. Or by the factor theorem, since the remainder is not equal to 0, the remainder is 3, we did not find a factor, or whatever it is. But yeah, I hope this was a straightforward lesson, and I hope you have fun doing synthetic division today.